So today we're going to start section 9.2. 9.2 is all about parabolas. You've done parabolas before. Okay? We're going to take your current knowledge of parabolas and we're going to expand upon it. Because right now, you only know how to do an opening up parabola and an opening down parabola. We're going to add into it left and right opening parabolas. We're going to add into it some more of the parts of a parabola, because right now you just know the vertex and how to find the vertex on it. So that's only one part. We're going to have, actually I like, you know how to do axis symmetry too, but then we're going to add in two more parts called the focus and the directrix. So let's start from the beginning. And the definition of a parabola is all points equidistant. What does equidistant mean? Equidistant. So same distance? Yeah. Okay. Right? So it's the set of all points that are the same distance from a point called the focus and a line called the directrix. Okay? So in a parabola, you need to have a line and you need to have a point. Okay? And so that line could be here. Let me see if I can, oh shoot, no, I should go like this. I should group them. Yeah, so that line could be here. That line could be here. That line could be, or I shouldn't say the line. The line and the relationship with the point could look like all of those. Okay, we're just going to deal with the four left, right, up, down directions. Okay, so this line then is called the directrix. And this point is called the focus. So the focus is located inside the parabola. Okay? And it is on something called the axis of symmetry. So inside means, that tells me that if the point is, or the focus, excuse me, is inside the parabola, that wherever that parabola is, that focus has to be inside of it. Okay? So if I'm so this relationship, see if I can get them all in there now. Okay, so this relationship, will always stay the same, where the focus is always inside of your parabola, the directrix is always outside your parabola. Okay, that relationship will always be like that. Your parabola never crosses the directrix. Okay? Your parabola never crosses the directrix. The directrix is a line located outside and it's perpendicular to the axis of symmetry. Okay? So the focus is inside the parabola. It's on the AOS, the axis of symmetry. Your directrix is outside your parabola, and it's perpendicular to your AOS. Yeah. Now what the definition is saying is let's go with, oops, not that one, this one. We'll go with orange. Okay. The definition is saying that if I have a point on my parabola, the distance from that point to the focus is the same as the distance to the directrix. For any point on the parabola, that distance, or those two distances, I should say, are the same. Okay? So if I'm way up here with it, this distance, oops, I went crooked. That distance is the same as that distance. Those two distances are the same. Okay. You're going to learn all about P today. Okay. P is the distance from the vertex to the focus and from the vertex to the directrix. Okay, so the distance P is from vertex to focus and vertex to directrix, which means then that I shouldn't say P, excuse me. I should say then that the vertex is halfway between the directrix and the focus. So my vertex here, because I have my directrix down here, that means then that the distance, that puts the vertex right there, and this distance here is P. That distance from the vertex to the directrix is P. Which means then, and that distance is 1, 2, 3, 4. That means if I go inside 4, 1, 2, 3, and 4, if I go right there is my focus. Because this distance here is also P. I can find P from the equation. Okay? The equation, the basic form of the equations is going to be either x is going to be squared or y is going to be squared. Okay? And then the coefficient on the non-squared term is equal to 4p. So the coefficient on the non-squared term is equal to 4p. So if I'm in an x squared case, that is an up or down opening parabola. So then p, I would go from my vertex, I would go down 4 to get my directrix if it's up opening, or I'd go up 4 to get my directrix if it's down opening, and vice versa to get my focus. A y squared parabola is a left opening or a right opening parabola, and so then my p distance would be left and right. So from my vertex, I would go 4 to the left to get my directrix if it opens to the right. I'd go 4 to the right to get my directrix if it opens left. And then vice versa for the focus. So I am going to now give you 5 steps to graph a parabola. Okay? Our goal coming out of today is to be able to graph a parabola. Now, you do you. Okay? These 5 steps I've refined over the years, and I think it's the most efficient way to go about answering all the questions that you will ever have about a parabola and produce the graph of a parabola. Okay? But again, I'm not saying that it's the only way. Okay? But if you follow these 5 steps, your life will be easier, I promise. Okay? All right? So, the first step in graphing a parabola is you've got to figure out which way it's going to open. Okay? So that you get a quick mental picture of what the shape of your parabola is going to look like. Okay? And to do that, you have to look at which variable is squared. Okay? If x is squared, it's an up-down parabola. It's one that you've seen since Algebra 1. If y is squared, that is a left or a right opening parabola. Okay? And then you look at the non-squared coefficient. So you look at that number there or that number there to determine which of the 2 directions it opens. If that coefficient is positive, it's going to open in the positive direction. Up, down, which one's the positive direction? Up is the positive direction and up and down. Okay? So if it's x squared and a positive non-squared coefficient, it's going to open up. If it's x squared and a negative coefficient on the y, it's going to open down. Okay? Left and right. Right is the positive direction. So if it's a positive non-squared coefficient, it's going to open to the right. Okay? Now, there's a lot of writing on this particular, oops, I did put them on there. Okay? There is a lot of writing on this particular slide, but this slide should only take you about 3 seconds to do. Okay? Because it's a mental, which variable is squared, positive non-squared coefficient, or negative non-squared coefficient. Okay? It's 2 questions that you should be able to answer just by looking at the equation. Okay? Okay, so that's step number 1. Getting a mental picture of which direction, up, down, left, or right, that parabola is going to open. Step number 2. you are going to identify the vertex. Okay? And remember that in math, especially when we're dealing with these things, okay, that if it's inside a set of parentheses, we have to think oppositely. Okay? So the vertex of this particular parabola is going to be I look at this number here to get my x part. It's -3, so I think oppositely because it's inside a set of a parentheses. So that's going to be +3. So my vertex is going to be at 3, comma, then I look at this number. It is also inside a set of a parentheses, so I think oppositely. So I'm thinking about -1. So the vertex of this particular parabola is at the point 3, comma, -1. Okay. Get yourself a little bit more practice with that. At this time, what I'd like you to do is I'd like you to identify for me the vertices of those two parabolas. Oops. Oh no, there we go. In the first one, in B, what is the vertex? 1, 0? Yep, 1, 0. Okay. I look here. For my x part, I think opposite, that's 1. I look here, there's nothing there. Don't even have to think opposite, because it's just 0. Okay. In the third one, in C, what is the vertex? No, it is not -7, comma, -2. We get Miles? -2, comma, -7, because the x is now over here and the y is, yep, we got to pay attention to which one you're pulling it from. So it's -2, comma, -7. It's not left to right, right? It's what's attached to it. Okay? Up here in these two, x came first, so that's why we looked at x. Down here, this is the x, thinking oppositely, it's -2. This is the y, thinking oppositely, it's -7. Okay? With me? Okay. All right. So, I'm going to go with that first one again. Okay? So, the first thing that we need to do here now, before we even get, we'll come back up to that. So, the first thing that I want to do is I want to do step number 1. Which way does this parabola open? Which way would this particular parabola open? What you got? Up and down, or you can only open one of the directions. Can't do both. What you got, Keon? Is it up? Why did you say up?
Because it's not negative and it's x squared.
It's okay, I like the fact that it's x squared. Yes. Okay, so that tells me it opens up or down. Agree with that? Okay. What's the second criteria?
Shouldn't it go down?
Why?
Coefficient's negative.
Because this number right here, this -12 is negative, so that tells me that this opens down. Okay. Because it's x squared, it's up or down. Because it's -12y, it opens down. Okay. Step number 2 then was find the vertex. So where is the vertex on this particular one? 3, -1. So we can graph that point 3, -1. Tap the brakes here. Let me expand my graph a little bit so that it gets a little bit bigger. Whoa. Okay. So my vertex here is at 3, -1. With me? Okay. Love it. Now, step number 3 says we need to identify the p-value, because the p-value is going to give us the distance from that vertex that we found in step number 2 to the focus, and from the vertex to the directrix. Okay? So if I'm looking at p-values now, here in step number 3, let me go down here. So in step number 3, 4p is the coefficient on the non-squared term. So this number right there is equal to 4p. So 4p is equal to -12. Right? Which means that p is equal to what? -3? Do we agree with p being -3? What is p again?
Oh, you can't have a negative distance.
Because it's a distance. So we drop the negative sign. We don't care about the negative sign. So p really is 3. It's positive because it's a distance. P is a distance. Okay? All right? So, because we're opening down, that means from my vertex, I'm going to go 1, 2, 3, down, and what's going to be 3 down from the vertex? The focus. So the focus is right there. At the point 3, -4. Right? P is also the distance from the vertex to the directrix. So since it opens down, which direction then is my directrix? What do you got? Up. So I go up 3, 1, 2, 3, and there is my directrix. What is the equation of my directrix? X is our vertical line. Y equals 2. Remember that. Okay? Might want to write that down too. Vertical lines are x equals some number. Horizontal lines are y equals some number. Because in this week, you're going to have horizontal and vertical lines in every problem. Okay? With me? Love it. Okay? So that was step 3. Step 4 now says, we can identify the width of our parabola. Okay? So let me tap the brakes here. Okay? So what I just did is so I'm up to speed on yours and didn't have it all on one page. Okay? So 4p now is also the width across my parabola through the focus. Okay? So negative 12, or 12 really, because we're talking that 4p distance and p is 3. So 12 here is my width across the parabola through the focus. Okay? So my width is 12, which means from the focus now, I am going to go half of that. The width is 12. The entire width is 12. So half of 12 is 6. So I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that entire width through the focus is 4p. You understand that? It's not 12 in each direction. It's 12 total. So it's 6 in each direction. Okay? Now I can draw my parabola. Because I've set my width. Okay? So our last step then is going to be step number 5. And step number 5 is going to be, we're going to put the axis of symmetry onto the graph. Okay? Remember that the axis of symmetry cuts the parabola in half, and it's perpendicular. What color haven't I used yet? Black. And perpendicular to the directrix. Through the vertex and the focus. Okay? So my axis of symmetry is perpendicular to my directrix, and it's the line that goes through the vertex and the focus. So in this particular case, it would be, oops, I want color, not that one, there we go. It would be, why did those get shifted? Man. No, 3-1, over here, this way. There it goes. For some reason the graph got shifted. Now I can go here, and here, and here, and here. So my axis of symmetry, my AOS, is the vertical line So vertical lines are what? X equals 3. So on a typical question, on a typical parabolic question, I will ask you for the graph. Okay? I will ask you for what the vertex is, so I need the point of the vertex, what the focus is, okay? So where that point is, what the line of, or what the axis of symmetry is, and what the directrix is. So there's 5 parts to each one of these problems. Okay? Graph, focus, vertex, directrix, axis of symmetry, which is basically the 5 steps. Okay? What I would like you to do now is, I think we can do it. Yep, we can do it for sure. For sure. I would like you to graph this one, y plus 7 quantity squared equals, I'll make it easy on you. I'll go 16 plus 2. Okay, I want you to graph that one for me now. All right, so first off, we have to figure out step number 1 told us which way it opens, right? Which way does this one open?
Right.
Right. Y is squared, coefficient is positive. Hey, hey, hey. So this one opens right. Okay. Second step, find us the vertex. Where is the vertex of this one? Quick. -2 comma -7. Okay. So that's my vertex. Now you don't necessarily have to label it with a V, but I will label it with a V. Okay? All right. Step number 3 was, oops, that's not in blue. Tap the brakes, Linz. Come on now. Step number 3 was find 4p. What is 4p? 16, which means that p then is 4, correct? So since it opens right, 4 to the right, 1, 2, 3, 4, is my focus. So the focus is at 2, comma, -7. Agree? 4 to the left then, 1, 2, 3, 4, is my directrix. It's a vertical line, so that's x, and it equals -6. Agree? Okay. Step number 4 said that my width through the focus is 16, which means I go up 8, 8, and I go down 8. Uh-oh, we're going to go off the graph. Are we scared to go off-roading? No. That allows me to draw in my parabola. That then allows me to find my axis of symmetry, which is y equals -7. This one. Yes, ma'am.
How do you know if it opens right?
The first thing that I have to look at on my right openingness is I look at, let me get back to step number 1. I look at which variable is squared. So if x is squared, it opens up or down. If y is squared, it opens left or right. And then the second thing I look at is I look at the non-squared coefficient, that 4p number. If that's positive, it's going to go up or right. If that's negative, it's going to go down or left. Okay?
So the
I'm listening.
symmetry is just the line that goes through the vertex and the focus point.
Correct. Okay? Good news and bad news. What do you want first? I have homework for you.
That's nothing new.
I know. You want the good news now?
Just the front side.
It's just the front side, and it's not, the worksheet's not due tomorrow. I'll just spot check it tomorrow for you. Okay? So I need you to have the front side of this worksheet done by tomorrow, which is 6 graphs, okay? Which you can handle, just like what we did right up here. Okay? And then tomorrow's homework is going to be back side. Okay?
But the front side isn't due tomorrow?
No, well, I'm going to check the front side tomorrow.
But you said, what's the spot check then?
I'm going to spot check the front side. I'm not going to collect it from you.
Got it.
Okay?
Do we get points
Okay.
for it?
You'll get points for it, yes, for having it done. Okay? But I'm not going to collect the worksheet from you tomorrow.